All right, guys, we should be live. Somebody there in the back row, do me a favor, just fire up into the YouTube mechanism there and just make sure that we are on and that we do have volume. I'm showing I'm bouncing 5 by 5 here. Check 1 2 there. Check 1 2 there. All right, so we should be good. Okay, guys, a couple of quick updates here, just quickly as we get going. Tate, grab the door. So my consternation yesterday with Eddie Bauer, that situation has been resolved. I did actually get a coat just in time for the snow to fly. So let it snow, let it snow, let it snow. It's kind of, what's that? No, it's not. This snow that we're getting here right now, down here maybe just rain, but up top, maybe it'll be preventing some of these core shots that I've heard so much about. So there's that. The balance of my Eddie Bauer winter survival gear is supposed to be here today. So to the folks at Eddie Bauer, well done. So there's that. The other thing having to do with the final. Your final is, as I saw it yesterday, scheduled for Tuesday morning, first thing, is it not? Okay. What time does your second final begin? I think it's after lunch, right? Isn't it? Yes. They do. On that Tuesday. Okay. Okay, here's why I'm asking this question. I need to know who has stuff immediately after. Well, it shouldn't be immediately after that. There should be a break. Because this is the option. We're scheduled to begin, when I saw the actual time frame, scheduled to begin at 8:15. What I saw, which is kind of odd. So, here's the problem. You need 2.5 hours. I want to give you 2.5 hours for the final. The whole purposes of these finals that we do here in this class is to prepare you for the FAA written. I want to create the exact conditions that you are going to be looking at in May when I drag your behinds to Grand Junction to take these FAA knowledge exams. Okay? So it's 2.5 hours is what I have to allow you to be able to do that. Now, here's the thing. I will promise you, if you are prepared for the final, if you're here beyond 90 minutes, I'll be shocked. The average time to take the finals and the exams is about 60 minutes. Most people take about an hour to do it because there are going to be questions you're going to answer just like that. You move on. 3 seconds, you move on. Okay? Then there are going to be questions that are going to require calculation. Okay? So that's kind of where we are. So just know that. Okay? Yes, dear.
So all of the questions that are going to be like...
Did I not explain this yesterday, or did I not? Okay, I explained it to some, but I think it was kind of at the end.
Yeah, it was kind of neat. So
okay.
All of the questions on our final are going to be questions that we've studied before in prepware in preparation.
They are going to be subjects that you have studied before. They may not be the same questions. If they are the same questions, it'll be purely accidental.
Wait, but...
Now, I'm not waiting.
I'm sorry.
Okay.
But they won't be the same questions over on our tests in this class, but they'll be on, like, say, there's like a 20-question block about weight and balance.
Hold on. What did you study for the previous tests?
The one that you click on the chapter.
Prepware and Big Blue, right? That's all you need to do. Same thing.
They'll be the same questions on the final as in prepware and Big Blue.
Possibly. Possibly. Same subject matter, Nothing we have not covered. I would never do that to you, except that one time by accident. And when you clicked on the wrong exam, by the way, remember that. So they will all be things that you have done before. But what I won't do, because sometimes what teachers will do is they'll pull questions from previous quizzes. I'm not doing that. That's not how you study for FAA exams. That doesn't help you. So, your question. Does everyone understand where the questions for the final are going to come from?
So every question on the final exam will be either in prepware or big blue.
That is correct.
So we can find, like, obviously we won't know because we won't know what's going to be on the final, but if there's going to be, we're going to have access to those questions, so we're, like, going to know them before we can study them. I can show you. Look, ready?
It's like a big quiz, sweetheart. That's all this is. All right, easy. We are also going to go up until this point because I am going to have someone here who is not concussed. I'm going to have someone stop me.
I can do it. I have a great brain.
Yeah. So what we're going to do is we're going to get through this last section here, and everything through today will be on the final. Everything that we do through today will be on the final. Yes, dear.
Sorry to have to bring it up, but do we have a quiz on Friday?
No. No. And the reason being is because we're going to mix this in. We're going to mix this in into the study prep for your final. Okay, so that's just this weather theory part. There aren't that many questions on the weather theory stuff of what we have gone through thus far. There are a couple, and you'll see them because you'll see what chapter that we go through here because this is, all you have to do is just look at this chapter and say, okay, what is it that we've covered, and this is what you're going to see here and be responsible for on the weather. And we'll talk about that again on Friday. Tate. Nothing will change. Every single quiz that we have done thus far, with the exception of what I had you draw with regard to the four-stroke engine, everything is going to be the way it is with the FAA, and the FAA is all multiple guess. Yes, dear.
Another question.
Oh, God. Okay, go ahead.
So, we're going to, say for example, there's 20 questions over weight and balance.
Okay, let me just go ahead and say this right now. We're going to be going over the balance of this chapter, and it's going to be on this test. The sooner we get at it today, the better. Go ahead.
Sorry.
That's okay.
Anyways, so but there are those 20 questions, and you're going to pick from those 20 questions the questions on the test.
Sweetheart, it is no different than the quizzes that I have been doing since last year.
Okay.
No different.
Okay.
The only difference is it's cumulative. Steph.
Are we going to be drawing the four-stroke engine?
No.
Okay. Do you happen to know which chapters we studied on prepware? If you don't, I can figure it out.
That's your responsibility.
Okay.
Next. Is that it? That's it. Here we go. Air masses and frontal weather. Frontal weather, air masses and frontal weather. We have talked indirectly about air masses and the lava lamp effect of kind of how air masses work. They rise, they fall, they move. We know that most air masses in the continental United States kind of either come from the north or from the northwest, west, or southwest and move easterly. Okay, we kind of know how that sort of goes. The differences have to do with a lot of different things, as we discussed yesterday. There's a lot of this, butterfly flapping their wings in Peking kind of a thing. And it is understanding on a cursory level, This is sort of this pedestrian general overview. The minutia of how all of this stuff works here with the air masses and the fronts is everything about aviation weather. And as I said yesterday, this aviation weather could be its own semester science class. It really could. So what we're getting and what you're seeing here are the basics and just a general understanding of where weather comes from, so that you can then begin to develop your own weather prognostication skills. I got skills. Okay, so there we go. So if we look at this, take a look at the first image that we have here on figure 30-11. If we think about how these things happen, is anything here really kind of different from that very first illustration that I drew for you, way back when? This is in essence kind of what happens. The big difference here is that having that ability of those three zones that we have, north of the equator, south of the equator, moving air in kind of their general circulatory fashion, and that's the only thing that's kind of different in this, but it has to do with the pressures behind something and pressure differential. How many of you understand osmosis? Do you guys know what osmosis is? What is osmosis?
It's like when there's like a membrane and like water or small molecules can pass it, but like bigger things can't.
You have a semi-permeable membrane that you have at some point, and what happens is that you have areas of higher concentrations of something that tend to move into areas of lower concentrations of something. They try to find that equilibrium. They try to find that balance. That's what our weather does, is it tries to find that balance, but it's in a blender, and it never happens, you know, and it's never one of those things, you know. That's kind of the same type of thing that happens. So you have changes in temperatures, changes in pressures. That's how stuff moves. Okay. Now, this one. Air mass movement. A couple of terms here. Subsidence, here in figure 30-12. Subsidence, that is sinking. Divergence, that's when stuff moves away from each other. Convergence, things come together. Okay? And then you have this rising element that you have here as well. And that rising element, that could be either convection, that could be due to, you know, the low pressure systems, etc. Okay? So just know those terms. Know what divergence and convergence are. Frontal weather. So we have all discussed what weather fronts look like on a map, kind of how they are. What we're going to talk about is sort of like how they actually move relative to the surface, as well as how they do aloft. So one of the things that you look at when you're looking at figure 30-13 is that you can see here that as a warm front moves, the airflow behind it is not always perpendicular to the actual front. You're going to have areas where you have other angular movements moving an actual front, and then so you have the winds that are behind the front, and you have the winds that are ahead of the front, and those can be moving in different directions. One of the things and one of the truisms that you'll see here is that every time that you cross a front, you can expect a change in temperature, you can expect a change in wind direction. Every time you cross a front, you can expect a change in temperature, wind direction. Okay? So let's take a look at I'm going to call this a typical warm front. It's kind of theoretic, only because of the fact that I don't know that there is such a thing as a typical front. I mean, you have certain characteristics that you can expect to see with a front, so I suppose that might be typical, but they can be just so different. And again, this is what I'm talking about when I say that we study all of this stuff on the ground, but what you experience up there can be very different. So as we look at this, you can see here that in the upper left-hand corner of figure 30-14, you'll see the warmer air there. And then you can see the cooler air below it. So what happens is that you have a series of clouds. In this case, we'll call these strata clouds. The stratus clouds are kind of moving in. They are visual indicators of that front. And those clouds come from the warmer air, which can hold more water vapor, being cooled to the dew point by the cooler air that it's overtaking, creating visible moisture. Right? This is some of that basic weather theory that we got. But here's one of the differences. A warm front will overtake a cold front kind of like this. It sort of squeezes that cold front kind of out ahead of it. I don't want to use like a rolling pin analogy here, but that's kind of what happens with that warm front overtaking a cold front. Normally, the weather associated with the collisions of the two different temperatured air masses isn't necessarily associated with violent weather. You're going to get rain in most cases. You can expect rain. You can expect reduced visibility as you go through these areas here. Virga is another. What is virga? Rain that doesn't reach the ground. So here again, as you look at this and as you think about this, why does virga happen? Because again, you have this moisture here falling into this into the cooler air here that can be has less water vapor in it.
So the air can no longer hold the moisture.
Well, above it. That's correct. The air can't hold the moisture above it. But below it, it has all kinds of room to suck up that moisture, and that's what happens. All that air gets sucked up, all that water, the water vapor, gets sucked up into the air before it reaches the ground. It just gets sucked up in the air. I mean, it gets absorbed, that water vapor gets absorbed in there because, again, it can. Okay? That's what virga is. The higher humidity is up here, the lower... And then it does, in that boundary area. Correct. Correct. Yeah, that's it. And then that can ultimately push clouds higher. So again, you have, different types of cloud formations that you're going to have, above it. But these cloud formations are rarely associated with the vertical development that you see when a cold front overtakes a warm front.
Wait, can you repeat that?
The cloud formations that you see when a warm front overtakes a cold front is not necessarily associated with the cloud vertical development as when a cold front overtakes a warm front. And you'll see visually here what we're talking about here in the book. And when you've done the reading, you'll know what's next.
Isn't a cooler front when a cold overtakes a warm or a warm overtakes a cold? Like, isn't it when like a cold catches up to a warm front?
I thought that was stationary.
Let's get in here because I think it's going to tell you. I kind of think I know, but let's wait till we get there. I don't want to tell you wrong. So this is kind of what happens here at this frontal passage. And remember, they talk about a frontal passage in relation to a fixed point on the ground. So you have a spot here. Here's the front that passes this fixed spot because the front is still the front. The front can still advance until something stops it, or until it runs out of the energy, or until the pressure changes.
And warm fronts move way faster than cold fronts, right?
Kind of the other way around. Normally, a cold front will advance faster than a warm front.
The warm front climb over.
Temperature inversions, warmer air. The air is less dense than the cooler air beneath it, and that's where you get that kind of that squeezing effect. It'll make more sense when you see the reverse here. This is kind of, they have an illustration here. You look at these, you see the altostratus clouds. Also in figure 30-15, you see some of the formations of some of the mammatus type of clouds underneath it. The Mimetis clouds are kind of those bubbly looking clouds, really, really dark underneath it, you know, kind of like that. And that's another kind of visual sign of instability there and the possibility of a drastic change in weather. This is another one here. And again, you can see that the clouds here are going to be more horizontal than vertical. Bullet points here, general characteristics of warm fronts. Know those bullet points there on 668. A warm front from the air. So this is figure 30-17. I mean, that's kind of a picture of a warm front through there. It's like where you have clouds really spread out horizontally. And that's kind of what they're trying to show there with that imagery. Okay?
So is a warm front usually horizontal moving air? Because isn't there like vertical moving air at the front of a squall line?
Not at a warm front. It's when a cold front overtakes a warm front. That's where you get the squall lines.
Okay, so it's horizontal moving air.
You're going to kind of see it. It's like I say, it's that air kind of moving like this. When you see the next picture that I'm going to show you, you'll see what the drastic difference. So again, notice this. Figure 30-18. Again, remember what I said. Change in temperature and a change in wind direction. Okay? So just kind of know how that works. It's rare that especially surface winds are going to be perpendicular to that front line. So again, if you look at a cold front, you know behind the teeth of that cold front, temperature is going to be cooler. And you know that ahead of that illustration, temperature is going to be warmer, right? Okay. So when you look at a cold front, and again, the FAA has some different imagery beyond what is included here in this book. And I kind of like the way the FAA does it. Cold front looks more like a freight train moving in underneath the warm air. It's like a cow catcher on a train. It normally, and the FAA shows the illustrations of basically that cold front coming in kind of like a pointy wedge like this, digging in underneath that warm air, shoving it straight to Jesus. This is where you get the vertical development of these cumulonimbus clouds. This is like the frontogenesis components of thunderstorms. Warm fronts overtaking cold fronts. Visibility could be an issue. You can expect steady rains, virga, but nothing very dramatic with regard to that actual weather. Cold fronts overtaking warm fronts, this is when you can expect the possibility of violent weather.
What is so the direction of frontal movement of the warm front there is this way as well?
It varies. The front's not necessarily moving unless they show that front is moving, because the warm front could be stationary with the cold front just getting shoved into it. So there could be relatively little movement in that warm front as that cold front overtakes it. But I've also seen it like this, guys. I have seen kind of like in the let me do this. I have seen in the U.S. I have seen this, and I'm not gonna do this here, but oh well, shoot, that's not what I wanted. Dang it! Come here. I wanted the blue. So here you have these are teeth. So there you have a cold front. Here you have a warm front, and you kind of have a cold front chasing a warm front. So you have enough movement here of the warm front to kind of have the meteorologists define it as a front, and then you have a cold front chasing it. And then you could have a warm front behind it. Butterfly. It's just, craziness. You learn the basics. And then you expect nuttiness. That's just kind of the way that goes. So we look here. Now we can see this cross-section here of this cold front coming in, and you see cumulus clouds now all of a sudden begin to become cumulonimbus clouds. Cumulonimbus rain clouds. This is where you start to see the vertical development. Okay?
And that's because the cold front's pushing it up.
Cold front comes right in underneath that warm front like a freight train and shoves it straight up. And it combines the ingredients to create violent weather. And we're going to talk about that here in just a second. Know these bullet points of some of the characteristics of a cold front? Okay. The reason that the clouds thicken and get lower, if you just look at the image above it, that's kind of why that happens. Because again, as that warm air is cooled, then what happens? Visible moisture. It precipitates out. Okay? So that's kind of what that happens. One of the sentences in this paragraph is, it's a good idea for pilots to consider avoiding, God bless you, the strong weather activity that accompanies many cold fronts. So that's the thing to remember. Cold fronts are usually associated with poor flying conditions. All right. I'm not going to ask Tyler to read this. Steph, read that first sentence of the occluded front for us, please.
Because cold fronts usually travel much faster than warm fronts, it often happens that a cold front overtakes a warm front, creating an occlusion or occluded front.
Okay. When you look at what happens in a real severe low pressure system, and that air gets sucked into that low pressure system counterclockwise, remember the movement of a low pressure system, this is kind of what happens with that cold front. You basically get, in this, you get a combination of, instead of like 2 air masses, you wind up with almost a third air mass that you're having to deal with in an occluded front. That's kind of what happens. Cold front, warm front, 2 air masses. Warm front, cold front, 2 air masses. But when you have this cold front that just basically Pac-Mans the warm front, where it doesn't have this, it just has this. And it overtakes that warm front, that's where you get weather in a blender. Cooper.
If there's a cold front but there's no warm front in front of it, will that still make all the other go?
Here's the thing. That cold front can't exist without that warm air, right? Without the difference. If there's not that measurable difference between it, there's no cold front. It's just warm air. It's got to be different enough, and that air mass and that variation of the temperature and pressure has to be significant enough for them to define it as a front. One of the things that I have tried to do over the last several years is to find out what is it specifically that meteorologists look at to define a front. What is the temperature differential, and what is the airspeed velocity that is required for them to define a front? Every time I have asked that question, I get a different answer. Some will say it's 8 degrees and 10 knots. Some will say it's 4 degrees and 8 knots. It just varies. Where you can see weather happening, that's when you definitely know that you've got some kind of front in that causing that weather to happen. As we get into the spring and we start looking at, especially across the plains states, and we start developing our 5-day rolling forecast for the nation, you'll start looking at weather a little bit differently. And you'll start seeing how, ooh, look at this, here it is. It's Monday afternoon. We've got a lot of warm air in the Gulf that appears to be moving north here from the Gulf. And up here, coming in out of Western Canada, I see a big cold front sweeping in like this. By Wednesday, I expect those two to converge. We could have some violent weather in the plains. And then we start seeing if we're as smart as we think we are. So that's part of what we'll do. Now, the one thing I will say about this in that figure 30-21 is it shows an occluded front on a weather map. Is that what an occluded front looks like now? It's not. Yes, dear.
Isn't an occluded front purple?
Correct. Correct. And where does the occluded front normally form? The northeast quadrant of a big low pressure system. That's where you can expect that to happen, because that is the way it normally works. The more it's able to kind of wrap around from that northeast side to get to the north, I've seen them where they're kind of in the northwestern quadrant, and you have this wicked looking loop across the top of a low on this. It's kind of crazy. But that's kind of where you would expect to see that occluded front. Okay? Now then, areas of low pressure. And we look here at what they're talking about here is this cold front occlusion. This is where they talk about these three air masses kind of converging and sort of this kind of this three-dimensional flow of air. The thing that the takeaway here on this, and this is where I will kind of disagree a little bit here with the illustration on 30-22. You see that you have warmer air above with the colder air below on this, which again, this is kind of that kind of Pac-Man school of fronts in this occlusion, is because you can also have cooler air above the warmer air again, and so you kind of have a warm air sandwich in there. But it is where they're showing the flow of that air, in this case from left to right on those illustrations, doesn't necessarily happen that way. Because when that low is that tight, that low pressure system, that air goes what? Counterclockwise, right? So what happens is you may have the cooler air at the surface that's being hit by even colder air below it, facing this way. And you can have this 2,000 feet above it almost 45 degrees off. And then air above that even stronger. So you have these areas of this greater and greater shearing effect between these temperature layers. So while they're showing the air masses kind of like this, that's not really the way that they work.
So it's like braided
almost. Almost. That's a great analogy. Braided. Kind of that tumbling effect of that air, which is why in even the big boys avoid occluded fronts, because it is the one non-thunderstorm related, in some cases, the non-thunderstorm related air activity that can be really hazardous structurally for an aircraft. You have no idea what's coming at you. And that's why it's so huge. This is why occluded fronts, especially for small aircraft, bad juju. Bad juju. Oh, I'm sorry. That's it. Occluded fronts are, I mean, yeah, yes, you could say tornadoes, yes, you could say hurricanes, but occluded fronts are the one non-thunderstorm related event. And again, it's not that you can't have thunderstorms with an occluded front, because sometimes you can, but then sometimes you can just have the occlusion there by itself that's not necessarily defined as a thunderstorm that can be hazardous to all aircraft. When we get to these weather warnings that we have for pilots, we're going to talk about airmets and sigmets. Airmets are going to be meteorologic reports that are primarily associated to airmen. They still say airmen. to pilots of smaller aircraft. Sigmets, significant weather, those apply to all aircraft. That's why you see sigmets associated with occluded fronts. I'm sorry? We haven't got there yet. But that, as I say, those are things that you're going to see there as well. Yes, you may indeed. Weather associated with a depression or a low pressure system. We've talked about this here as well. Troughs of low pressure. You'll see troughs. You'll see troughs outlined on maps. What is a trough of low pressure? Okay. Stand by. Buckle up. All right, kick it.
Is it the lowest part of the low pressure system?
Not necessarily. We think of a low pressure system as being what? Circular, correct? It's like this. It's a trough. So for instance, and I don't have orange on here, pretend that I'm drawing in orange.
Is this from like a sky perspective or like?
Vertical. It's a vertical line, like a vertical, think of it as like a little wall. Think of it as like a little wall. So for instance, if you see figure 30-24, you see 30-24, what happens with low pressure? Low pressure rises. The air in a low pressure, that air rises, right? Well, in a low pressure, it rises and it circulates counterclockwise. In a trough, it doesn't. In a trough, what will happen is that, pretend I'm writing here in orange, because that's what you'll see. So let's say along the Rocky Mountains. You'll see orange lines like this indicating a trough. So this is what we call a plan view on this. This is when you're looking down from the sky down to the ground, and you see this line. It's like a wall. But when you look at it from a plan view standpoint, what's happening is that air is getting sucked up, but then up top you get divergence. So you get convergence down here, convergence at the surface, and up top you get divergence. And so what you want to know is, give me the height of this trough. Where is that air changing? Well, we can look at these troughs and we can see, and here's why it's important to know about these troughs of these low pressures. Because you can be flying along here and just, fat and happy, and down here at the surface, because again, remember, where's that air flowing in here in a convergence? Okay, so here you go. You've got this air flowing here, creating this convergence up here, but at some point, altitude-wise, what's going to happen to this air as it dumps out of the top? Well, it's going to come back this way. So now all of a sudden, you've planned on a tailwind, and then you change your altitude. Now all of a sudden, you got a headwind.
Can you, if they're not, how tall are they usually? Can you fly over them, or are they really tall?
In most cases, they're kind of tall for us to come over. And in some cases where it dumps out like that, and that can be okay, because, you know, we can be in a boundary here, you know, and let's call this, you know, 12,000 feet. And so in some cases they won't affect us. But other cases, the troughs don't have that vertical size to that wall, and this may be here at 8,000 feet.
Do they have width? Like, are they like the middle part?
They're relatively narrow bands. I don't know that I could tell you what the typical width of that is going to be. But the big thing of this is that with a trough, what do you get with a front? Temperature, changes in winds. In this case, with a trough, as opposed to a front, the big difference here is going to be the wind. Now, the other effect that you could possibly get from a trough like this also is going to be this. Depending upon where it is. Let's just say this is cold. Let's just say this is warm. What's going to happen here? And especially with that, with just the pressures itself, let alone forget the temperatures, just the pressures itself shooting that air straight up.
Keep like building clouds.
Exactly. Correct. As I said on the very first day that we're talking about weather theory, is that you have kind of the basics, but then you always have exceptions to things. You look at some of these fronts as having these nice, neat lines of like preceding temperatures, preceding things like this, and then other times you've got this wild-looking, goofy, you know, wave-looking thing that happens because of something else that is occurring somewhere else. All of a sudden you got a break in the clouds. Now all of a sudden here over this brown surface you've had enough sun that all of a sudden creates some convection over here that just really kind of throws off the weatherman's map. So it's like it just always changes. So if you're looking here at figure 30-16, I'm sorry, 30-26, here's a thing that you can kind of look at. So if you look at 30-26 and you see that cold air on the lower portion of this, and you see where you have a cold air here and you've got that warm air kind of right here like this, and they're kind of joined at that point, what is it that you could expect throughout the day to happen in the northeastern quadrant? Because first of all, those two are touching those lines because there's a low pressure system right there. That's what's pulling those things around counterclockwise. What is it that you can expect to see happen in that northeastern quadrant a little bit later on as that develops? An occlusion. It's not showing it yet, but there's a good chance of that happening. Okay? Hurricanes, tropical revolving storms, well, there you go. That's what we have. Low pressure systems, areas of low pressure, generally associated with poorer flying conditions. High pressure systems, generally associated with better flying conditions. It creates more stability because you don't have something shoving everything up. Now you have things that are settling, coming down. Okay? Generally associated with better flying conditions. So in this case, what you're seeing there, instead of a trough of low pressure, now you have a ridge of high pressure. So that whole thing that I drew for you about the trough, like this, the ridge of high pressure is like that. It's the opposite. Generally better flying conditions. Ridge of high pressure. Boom. There you go. A coal. You ever heard of, like, in some I guess some people who sail and they do things, you know, on the water, and they get to like the doldrums. They refer to things as the doldrums, where the sailors, they have no air pushing the sails. That's kind of like a coal. You have this area between these front pieces. Cooper, is your back okay? Uh-oh. So that's kind of what happens here. So when you see areas on a map that you look at, okay, I've got a high pressure system here, high pressure system here, low pressure system here, low pressure system here, then you can kind of extrapolate what is this air going to do here in the middle. Normally, it's going to be a magic carpet flight through that area. Oh, by the way, look at that. We're done with that chapter. Yes, dear. Yes, dear.
Okay, but so on these convections where they're the ones like
Well, now remember. Now remember. Low pressure troughs and high pressure ridges. Don't confuse those with convective activity, because they're a little bit different. Convective activity is driven by that change in temperature, and that's what moves that air mass up. The low pressure system, it's doing it because of just the pressure of the air itself, not necessarily convection. I just didn't want you to confuse that.
thank you. And
My pleasure.
so for this, when you're flying through the part that's either going like it's say for low pressure, for example, it's converging down here and then it's going up and then it's diverging up here. What's going on if you're flying through the part that's just going up?
What do you think?
Kind of float?
Think it's going to be a little turbulent? Yep. What's going to happen when you fly through that part on a ridge of high pressure? It's going to be a little turbulent. And you have to know is that when you go through that low pressure trough, you can expect air movement from below. High pressure ridges, stuff kind of moving you down. Okay?
When you see a coal and you're like, well, that's obviously probably in like an optimal place to fly. If you fly through that, you can just fly through that, but I mean, like, you're not trying to avoid the low pressure system, so you kind of like hug the high pressure system and fly through it.
That's what I do. Depends. You can have a coal that could be the size of a county. You could have a coal that could be the size of a state. Mm-hmm. We've seen it. I have flown through an area when I was going to Missouri one time in the Diamond, flying through the northern part of Oklahoma, the southern part of Kansas. And there was high pressure above and below, low pressure to the west and to the east. And when I flew through there, I have never flown as far without a ripple. And it was just like, you know, pretty amazing, actually. And you're looking and you're thinking, wow, when does this magic carpet ride end? And it really wasn't until I got to Missouri that you know, you get a little bump or two, which is normal when you fly. I mean, that's just part of it. But it was just like, wow, sweet. Okay. Now, time-wise, it is almost 9 o'clock. How long do I have, you guys? 9:40.
Are we going to talk about like the opportunities for
That is precisely what we're going to talk about after we talk about what the final is going to be looking like. Okay? It will include everything from page 1 to right here. Okay? I'm sorry?
Even like weather report. What's the next chapter?
Yes. Yes. Next chapter, which is going to be 31. Stand by. Come on, baby. Visibility.
So we're going through all of weather and then we're going to go back.
Well, not this.
Not all of weather. This is just that first little taste of weather theory. Okay? So, let's look at, where'd it go? Big Blue. Hang on.
So we should just, everything we've done in Big Blue plus this, we should go over and redo again and then do that all
Yes. Hang on here. I got the cutest card. Look at that. Look at that. Look at that red hat. It looks so Scottish. Oh, aye. Kylie, it looks so Scottish. Well done, lass.
It's my dad's, but then I was like, oh, hey, this is funny.
This is funny. How does Dad feel about that? Hey, Dad, I like your funny hat. Funny? I thought that was high fashion. Okay, so when we look at weather, let's look at in Big Blue, chapter 6. Okay, chapter 6. Let's take a look here, and I'm just going to read you the table of contents of chapter 6 in Big Blue. And tell me what you think that you need to study on this. The heating of the earth. Okay, yeah, all right. Circulation and wind. Yeah. Temperature. Yeah. Moisture. Yeah. Air masses and fronts. Stability of the atmosphere. Uh-huh. Have we gotten into clouds yet? Have we gotten into turbulence to some degree, but not the way we're going to? No. Thunderstorms? No, we haven't gotten into thunderstorms yet. What about wind shear? Yes. Okay. Icing? Not really. Fog? Not really. Frost? Not really. They all have corresponding page numbers to all those things. So boom, there you go. Beyond that, let me ask you this. Basic aerodynamics. Okay, so that's all of chapter 1. Got it? Aircraft systems. All of chapter 2. Flight instruments. All of chapter 3. Regulations. All of chapter 4. Okay? Aircraft performance. Okay? Because we have not gotten into the takeoff and landing stuff yet, have we? So the weight and balance. The weight and balance sections of aircraft performance. That's 8. That's 8. Navigation? Not yet. En route flight? Not yet. Communications? Not yet. How about procedures and airport operations? This is the tough one. Chapter 5 is the tough one. Where do we find fitness for flight? You're going to find it in chapter 5. So the physiology elements of things, that's going to come from chapter 5. And this is the hard part of the way that this is set up right now. Your textbook, the very first thing that we start talking about is we talk about the human element, human factors. They put human factors in chapter 5 with airport operations. So uncontrolled and towered airports. We haven't gotten to that yet, have we? Airport markings, airport lighting, visual approach slope indicators, surface operations, chart supplements, fitness for flight. Yes. 1. Chapter 1 or 2? Oh, in prep work. In this, chapter 5. In the book, it's chapter 1. 1 or 2. It's the first thing that we did. ADM. Yes. That's part of it. Collision avoidance. Yes. Aircraft lighting. Yes. So everything in Big Blue from chapter 5, from fitness for flight down, is included in that. Everything in there from Chapter 5 in Big Blue, from fitness for flight, including aeronautical decision making, collision avoidance, and aircraft lighting. That will be part of this.
Are we going to have to know all of the V speeds?
That's going to be, yes, if we have covered it in class, if we have covered that, yes, that's part of instruments.
We just haven't been quizzed on it.
So on V speeds,
Yeah.
Cooper, I think there are a few questions sprinkled in.
Yeah,
about
there's like
these
VA
speeds.
and,
It's like, what's
okay, all right,
and VLE and all that.
all right. So on Friday, we're getting a list together. On Friday, V speeds.
these speeds
Live it, learn it, love it, know it.
on Friday?
We're not doing a quiz, but know what they are. V speeds. And remember, which is the real tricky one? VNO. Thank you, dear. VNO. Normal operation is what NO stands for, but it actually means structural cruising speed, which sometimes people confuse with VNE. Well, what's the fastest I can go before stuff starts falling off my airplane? Well, that's not really the technical definition of what that is.
So no quiz, but just refresh your memory
Correct.
on them before Friday.
Yep,
Oh, I have a question.
I have an answer.
On the airspeed indicator, the red notch is like the never exceed speed.
Mhm.
But then is it VNE? No.
Yeah, VNE is
Yep, that's that. And then there's another certain point where it's like the maximum structural cruising speed, but that's below the never exceed.
that's the top of the green arc and the bottom of the yellow.
So how can you go into the yellow without stuff?
Because in smooth air operation only, that's what that yellow arc means. That you can go faster than the top of the green arc, VNO, in smooth air only. So, like that flight through Kansas, just pour the coals to it. But if it starts getting lumpy, what are you going to do? Back off on that throttle. Okay? Then, in a descent, because normally in most training aircraft, the only time that you're ever going to see VNE is if you're, diving. Okay? So, in that again is one of those things that you really kind of have to watch. Because there are some aircraft, the Diamond is one of them, it's pretty slippery. And it's one of those airplanes that you start pointing it downhill, she's going to want to go. Okay? Good?
Great.
Beautiful.
Go. So when we go to take the exam, will the exam questions be the same questions as the one on there?
Question was, when we go to take the exam, my assumption is that she means in Grand Junction. Will the questions be the same? To about a 92% certainty. Okay? And here's why we use prepware. ASA updates prepware. Who's going to come by here, pick up my book, and update my book? Yeah, maybe me. Okay? That may be it. The reason that we do the online component is because it gives us access to updated questions in that data bank. The FAA will absolutely be using the most updated questions in their data bank. Okay? They try to stay on top of what those new questions are as they come through, but you have to understand the FAA doesn't send a list to the publishers. The way that the publishers find out is they have people like me that take those tests that report back to them and to say, hey, listen, here's a question that I saw here today that wasn't on that test. They won't let you write those down. They won't let you leave that exam with any notes that you have. They'll give you paper. You have to give that paper back. A lot of places will say, I'm going to give you 8 sheets of paper. I need you to give me 8 sheets of paper back. Doesn't matter.
Yeah, we have to do that.
Yeah. You got to give it back. Okay? You don't get to draw like you can in your books on those paper illustrations. they give you a plastic overlay, and you have to lay that piece of plastic over the image in the book and then draw with a special kind of a pen, like a dry erase pen.
Oh, it's like a laminated sheet that you can.
That's it. It's just an overlay. So here's the thing about using those overlays, and you guys don't have to worry about that until May. In April, we'll start practicing with these, but I'll just tell you this here right now that I've kind of got your, rapt attention. So on a page, here's the page of the whatever it is itself. Inside that is going to be the image. So this is going to be the image. Your overlay is going to be the size of your page. So your overlay is going to be that size. So when you lay the overlay on there, the very first thing you do is you take that pen, and when you lay it on there and you're holding it very, very still, mark the corners. Mark the corners before you mark anything else. This way, if for whatever reason, as you're drawing on that overlay, if your hand moves or something, you can always realign the corners. Okay. That's it. All right. So that's how you'll use those. I'm thinking. Name that movie.
If you're descending and you're going too fast, will pulling back the throttle, like to put in the first notch of flaps, will that slow you down enough?
It depends. What is your rate of descent? How steep is your angle of descent? Reducing that throttle before you descend is the biggie. And then knowing that if you have step downs, so for instance, if you're looking at, and the question was, for those that couldn't hear, if you're descending in an airplane and you just pull the throttle during your descent, is that going to be enough to slow your airplane down to start adding flaps? Okay. So in this case, what can happen is that in most cases, your descent is going to kind of look like this until you come in, to land. So you have what we call step downs. So in most cases, depending upon your air conditions, you want to maintain your speed as best you can until you get to an area where you're actually going to be beginning your approach. So it's going to be then the big one where you want to make sure that you have contained your speed is in that last step down, so that you slow during that level period, which is going to allow you, once you reduce power, to slow down the quickest, the most efficiently. Get down to a speed there that's going to allow flap deployment to begin your approach. Don't begin your approach and then think, okay, how do I slow down to get flaps in? In my airplane, you can't. You won't be able to. And the other thing that you have to worry about, especially if you start getting into more complex aircraft with turbocharging systems on there, you have to be concerned about how quickly you reduce power. These are great big engines, and those turbochargers on there, all that stuff gets hot. When that stuff the metal gets hot and cool, it expands and contracts. What you don't want to do is shock cool those engines, because that's bad. It diminishes engine life. You could have bad things happen doing that. So you have to start reducing that power gradually. The rule of thumb that they give you is 1 inch of manifold pressure per minute is going to be about the fastest that you want to start reducing power. And you have to start thinking about that a long way out here.
And it also differs between aircraft.
Big time.
You have to start doing that a lot earlier than.
Big time. It's kind of like why when you're flying on, let's say, I'm just going to say Southwest, You know, if you're flying on Southwest and you notice that you're 210 miles away from Denver and you start descending. Well, before they start doing that, one of the things that you're going to start noticing before they descend is all of a sudden you notice you start leaning into your seats, your straps a little bit more. That's because they're doing what? They're reducing power. They're slowing down. That a girl. They start reducing that power, then they point the nose downhill for this exact reason. Those engines, they don't have to worry about the shock cooling as much, but what they have to worry about is they have to worry about the fact that if I do this to my airplane, you know, with full power, stuff happens now. If they do it, there's a big lag. And when they start reducing that power, pulling it back, nothing's going to happen for a while. So you really have to stay ahead of that airplane and staying ahead of your systems so that you get to the right altitude at the right airspeed at the right spot in all the right conditions. So questions? Diego, do you have your hand up? Okay. Okay. Let me ask. Oh, Tate, go ahead.
What do you do if you have to make an emergency landing
In snow? I could always begin the answer to every one of these questions. And the question was, for those of you that may not have heard, what do you do if you need to make an emergency landing in the snow? I could always begin these questions with, it depends. First of all, before I get to that question, Tate, let me ask another question, because I've got you guys here. It's 9:10. If I offered, do you guys have finals on Monday? Oh, okay. Oh, okay. I was going to offer a study session late in the afternoon on Monday. You want to do that? What time works for you guys to be able to do it? Give me an idea. I've heard 4. I've heard 4. Whatever works for me, promote that, kid. Okay? So I've got 4. I've got 4. 4 o'clock? So, Monday, 4 p.m., here in the aerodrome. This is a study session. It's kind of like Taco Tuesday on steroids. We're going to have the cream and the clear here with this. Barry Bonds reference there for those of you. Okay, anyway. Study session Monday, 4 o'clock. Here. Okay? I have one condition. One condition. Don't just show up. Oh, yeah, I like food. Yeah, I like food.
Bring tacos.
That'd be good. Bring questions. Don't just come here and be expected to be entertained. Come here with questions. So, in order for that to happen, you're going to need to go through this material before and then get to a place to say, oh, man, you know what? I still get confused with blah. Okay? And then let me help you with that then at 4 o'clock on Monday. My gift to you. Well, if I'm going to be here, I'm going to be here for a couple hours. I'm just going to say 4 to 6. Let's just say 4 to 6. If you guys are done, you get done earlier and you're set, ready to go, we'll leave earlier. Okay. Look for, I would assume that there will be other educators in the building. If not, look for a sign. When I unlock the building for students at the front, because I can't use this back door here in the wintertime, when I unlock the door up front for students, I unlock that side door. Which door do I unlock? the side door. So I've had students that said, oh, I couldn't get in, so I left. Dude, side door. Okay, that's the one I'm going to unlock. Now, sometimes what happens, well-meaning educators leaving the building thinking, oh, why is this unlocked? And we'll lock it. If that happens, everybody has my cell, correct? Text me. Okay? 4 o'clock, Monday. We should have food. What should we have? I've got coffee. Yeah. Yeah. Even as concussed as it is, I like where Tyler's head's at. Pizza donut, pizza pie. Something, yeah. Okay, so guys, bring questions. All right? Yeah. Off you go. I'm sorry? It'll be a videoed class, so I'm going to record a class for you guys for Friday. So Mrs. Benton will be here.
Oh, right, because you're going to be in, wait for it? Austin, Texas.
Yeah, Austin. I'll be in Austin. Well done.
Cool.
And then it'll be just kind of that, and then it will be an extra study session for you on Friday. So again, it'll be a recap, a video recap of what we're gonna cover, and then time to study. Do not waste it. Now, anybody here, anybody ever find themselves to be somewhat prone to procrastination? Thank you for being honest. Thank you.
I always get my stuff done, though.
How many of you are addicted to stress? And here's why I ask this question, is because sometimes people do better under stress than others. And some other times, stress for other people can be incapacitating. And I get that. I get that. Here's the thing. Let's try to make Tuesday a stress-free exercise. And how do we do that? We prepare. We prepare. Yes, it's a good thought, Gavin, but no, the final will not be extra credit. The final will be a big grade. Okay? Okay?
This is 20%.
Here's how I do this. Here's the question. Do I weight the final? Wait. Thank you. Here's how I do it. The benevolent big bald man. That's the triple BBM to you. Okay. I do that in what is best for you. What is the best way to help your situation? And that's how I look at this. If you guys do well on this final, it would be in your best interest if I weighted the final towards your semester grade, would it not? So let me ask you a question. Here's a chance. Here's a chance for you to knock this sucker out to park. Okay. So, but here's the deal. If I weight it for everybody. If I don't weight it, it's not weighted for everybody. I don't do it individually because that's not fair. So here's the thing. If the majority of the students do well on this final, and it is better for the majority for that to be weighted, understand that's what will happen. But a weighted final exam can be a double-edged sword. Do you understand what I'm saying to you? You can all knock it out of the park, or you can all suck. Ah. Ah. I don't know who this is, so I'm not answering. Okay, so understand it will be in your best interest to do well on this exam. Diego. All right, so here's the thing. The way that we have... Go ahead.
Story, quit interrupting the teacher. Sorry. This child, what are we going to do with her?
It is when 1 does not actually equal 1. 1 could equal 1.5. 1 could equal 1.7.
So like when you get 10 points on your test, if it's weighted, it could like make your grade go up a whole percentage point rather than just go up a whole
Wait, I have a question.
Correct.
Are you saying, because you said that there was 5 bonus questions integrated into the final, if we get all those bonus questions and we got over 100% and the grade happens to be weighted, does that mean we could potentially end with over 100%?
That's correct.
Okay, guys,
I'm gonna do that.
we're gonna all really do well.
That is correct. Kylie.
So,
I still have to answer Tate's question, so let's hurry.
I'm sorry.
That's okay.
For the weighting, what do you define as like if the majority gets above a certain percentage, weighted?
It, it depends. It depends on how I'm feeling that day.
So is it like an 85% or better you'd weight, or a 95% or better you'd weight?
Let's see how we do. Here's my expectation. My expectation is that everybody in here do better than 90%. Now, in that case, if I weight this and I add, let's just say that I add 20%. Let's just say that I do that. And I add 20% to that, or I add 25% to that. That can be pretty huge. That can be significant. Okay?
You would weight it 20%.
Possibly. Yeah. But again, here's the thing. The reason that I am prone to weighting the final is because it is more of an example, and it is a, in my view, a better demonstration of what you know, and understanding that everything we do here is cumulative, which is harder than some of the other tests that are given. Okay? So by doing that, I am willing to reward you for those efforts. Okay? Make sense? Okay. Now, Tate, what do you have to do if you have to make an emergency landing in the snow? Depends. Am I in Minnesota, where the temperature has been below 0 for like ever, and that snow is like landing in the parking lot? That's the case, gear down. Am I landing in the Freshie on a deal like that? If I have a choice, I'm gear up. It's like landing in water almost. That's the thing. How do you know? In some cases, it doesn't matter. In some cases, here's the thing. In the Diamond, in my airplane, my gear is down and welded. Up and down doesn't matter. So what am I going to do? I'm going to land in a full stall, as high of a nose-up attitude as I possibly can. My airplane is a little bit different in the fact that I've got a great big ski down underneath the bottom of this sucker, down here, that cargo pod. So that's going to help absorb a lot, I hope, if that ever happens. Yeah, okay? But I'm going to land in a full stall in as high of a nose-up attitude as possible. Full flaps as slow as I possibly can. This is it. This is an emergency landing in the snow. This is an emergency landing in the snow. That was the question. If you're landing on a snow-packed runway, now what are you going to do? First of all, you have to recognize that your braking action will be nil, meaning you're not going to have brakes. But that's okay. You know why? You've been taught how to operate that aircraft with the energy management necessary to not have to use your brakes, right? Woohoo! Gavin? Oh, we are. Yeah, we are. Yeah, I know. But it's still after, right? Okay, so there it is. I have to do updates to the machines. So we're going to get that after the final. As we start the second semester, that's when we'll start doing that. Okay. And that's one of the big things is that during finals week, that's what I get to do. After you guys are done with doing your deal, I get to spend the rest of the week, with the exception of the middle school classes and a couple of other classes, of going through here and getting all of these machines updated and ready to roll, because we got to. Okay? Questions?
If we finish the final early during the final period, do we have to stay until the end?
It's a great point. Tyler asked the question, if you finish the final early, do you have to stay? The answer to that question is yes. Also, because again, what they don't want is that during finals week, they don't want students just roaming around, okay, or leaving campus or whatever until that period is done. This takes me back to the other question that I have. Can we start at 8 a.m. on that Tuesday? Can we start at 8 a.m. on Tuesday? I need to hear from everybody.
I will do my best. I think the problem is that when everybody else is get off at the bus stop.
Here's the thing. All right, there is something called academic integrity. To make these exams work, this is like the one time that you actually see teachers take testing serious with things, is that we all have to begin at the same time. We all have to end, well, not end, but we all have to begin at the same time, because everything has to be equitable. Everything has to be fair during this test. If we cannot all begin at 8 a.m., we will all begin at 8:15. Okay? If we do that, understand, I am giving you 2.5 hours to take this test. 2.5 hours. So that means 10:45, right? Your next final would be when? So you'd have 30 minutes, which is still a lot of time. I have to give you that amount of time because that's what I have to do with the FAA. So what that means is you have to recognize that you may only have a 30-minute break. Oh, geez, only 30 minutes. Well, that's an eternity compared to what some of the testing schedules that you guys are going to have in college. So just know it does not sound as though that we can begin until 8:15 because Cooper's got hockey. Well, here's the thing. We need to know. Can you let me? Are you sure? Anybody else? Anybody else? I need to know. We all good for 8 o'clock? Hands up for 8 o'clock. Up, up. That means elbows off the table. All right. Hands down for something else. See what I did there? Don't understand the question. Tyler's like, I don't know. I'm concussed. Okay, we'll begin at 8 a.m. on Tuesday. 8 a.m. on Tuesday. That will make sure that you have plenty of time before your next final. We'll reiterate this on our study session Monday at 4.
Mr. R, I'm sorry. If we show up, if we start at 8, but we're finished by 10:15, which is the end of the official time.
If end of the official class period, you can go.
Okay. Even though that's all we'll have, we'll probably have to use every
No, I don't think you will. The class is scheduled to end, I think, at 10:15, right? So whatever the official end of that class period is when you can go, because that's school. I'm allowing you that additional time for FAA. Okay? So now, what do you do after you're done with your exam?
Do you get your grade back right away?
You're taking it on prepware. Yes. No, it's on prepware. It's on prepware. Remember, this is why we do prepware, is so that it can be consistent all the way through with everything. So yes, it's electronic. It's on prepware.
Oh yeah, and you said the first day of class, I'm giving you the answers to your final today.
Now, if someone needs some form of special consideration to take the test on paper, I need a darn good excuse why. And you need to understand that when you take this test for the FAA, you must take it electronically. It's why we do it this way. Okay? So let me know if there is a compelling reason for me to administer this test on paper. All right? Academic integrity. Do not force me to be a bad guy. Ain't gonna be no cheating. Okay. Tables are gonna be spread out. Okay. Do not let your eyes roam. Understand that going to the bathroom in the middle of the test is always a red flag for a teacher. Okay. All electronic devices will be kept and maintained up here at the front of the class. You can get them when you're done. We're just going to be, integrity is going to be a big part of everything we do. And this is no different. Yes, dear.
Are we allowed to take the test on our own devices?
Like our own computer.
Oh, yeah. Just like you've been doing your quizzes. No different.
But just, are we just not gonna be allowed to have any other tabs open besides the exam?
Don't think that I won't be walking around. Don't think that I'm not able to determine if you have an overlay and a screen open on something else with something else. It's not my first rodeo. Okay?
Well, yeah, but say for example, we accidentally, sometimes when you go into prepware, I would just look up prepware and then I'd click it and it'd send me to another tab. If I have two tabs open, will that be an issue?
Yes. Close the other one. Close the one you don't need. Close the one you don't need. All right? I will also be letting our technology coordinator here understand that we're taking an exam, a final exam, and that we need to do everything that we can to ensure the fact that we have internet connectivity electronically. Easy.
Will there be jazz music?
I can't have music playing during the final. I know. I know. What's that? No earphones, no nothing. They're not going to let you listen to music in Grand Junction. Calculators. Calculators. I will have them for you. I know you like using your own.
Should we bring our plotter?
What did you need to take your quizzes before?
Plotter, our book, our figures book? Yay.
Yes. Okay. All right. Any other questions? Off you go.